guys, welcome back to John's Workshop, and in this video we're going to be trying to make a cheap keyless chuck that I purchased from Banggood that I showed in my recent blether video number 8. So go back and have a quick look at that. Fit my lathe. So I'm just going to bring you back in a little bit closer to the bench and show you what I mean by that. Okay, so here's the issue, guys. So this is the keyless chuck that I bought from Banggood. It's a 1 to 16mm scope or range, and it's a JT6, which refers to the taper in the back here. And I ordered with it the respective Morse Taper 3 Arbor, which is this one, which I don't know if this will show up on the camera. So this is a Mark III, which is a 3 Morse taper, and a B18 as opposed to a JT6. So the taper that's on this end, I believe, is the wrong one. Now when I ordered them, I made sure they were a matched pair so that it would go together. Now as it turns out, they do actually go together to a degree, and really I could probably use it like that, although that doesn't look good and it's not good. So we've got centres in each end, so we can hold this thing between centres. And then what I'm going to do now, just quickly while I'm talking, I'm just going to paint some Dykem on here and just let that dry while we're discussing how we're going to go about this. That'll do. So we'll just let that dry off. And so if I put this thing between centres, it should run perfectly true, and we can check that by clocking the Morse taper in. I'm presuming this has been ground between centres. It's ground on both diameters, so it will have been ground between these centres. So hopefully if I hold between the same centres, the Morse Taper 3 bit should be bang on, and then we can turn the diameter on this end. Now what I did do, let's find it again, let's find any file, not that one, any file other than that file. Let's go for that one. What I have done on here is just run a file over this chamfer, and you know that the file is biting and it is digging in. So this thing isn't hardened. It may be hardened to a degree, but it's certainly, I'm certainly going to be able to turn that with carbide inserted tooling. So now what I'm going to do, I'm just going to, that Dykem's dried off now, I'm just going to make sure that taper's totally clean in there. We're going to drop that in and just spin it, take it out, and what you can see there is full contact all the way down. So the taper that's on this is the right taper in terms of angle, but it's just clearly the wrong size in terms of fitting in the back of the chuck. So that makes this job pretty easy really. Once I get this thing held between centres properly, I can then clock on this existing taper, set my compound slide until I'm getting absolutely zero across there, and then I know that I'm going to be right to return that and take enough material off until the chuck fits nicely onto that taper. So that's a nice easy job at first sight. Then when I started looking at how do I hold this thing between centres, so dead easy. You know, I can turn a 60-degree cone on a bit of bar in the chuck, which is what I always do this end. Tailstock with a revolving centre in this end, no problem at all. But I need something to drive it with. Okay, we're over at the lathe. What I've done there is I've just thrown a bit of bar in, and we've just turned a 60-degree cone on it, which I'm going to need anyway, but I can't use it at this setup, and you'll see why. So I've only got one lathe dog or carrier, which is this one. At the moment I don't have any more, and if I try and put this onto the flat end of the Morse taper this way, which is the way I would have to grip it, you would never want to grip it that way in case it spins, because if it spins it comes loose. So I've got to grip it on the smallest and thinnest end, which is this way, which isn't a good fit into this lathe dog for a start, and also I don't have enough thread to nip up on that. I could maybe just about nip up on this taper further up, but again, not good practice, because you nip up and if there's any slight movement that way, the whole thing comes loose again. So this needs to be gripping on a parallel diameter or a parallel face. So this lathe dog is not a good thing for this. And also, if I go back to the chuck, and we'll assume that by whatever reason we've made this good, if you actually look where this lathe dog sits, I know it's not showing up there, actually it's out of shot, there you go. You can see there that the actual lathe dog itself is pretty much too big for this chuck, so it doesn't really work on this chuck. It would probably work on the 4-jaw, but it certainly won't work on this 3-jaw. So we'll go back to the bench now and talk around how we're going to get around that. Okay, so we're back at the bench, and you may have wondered what this was doing on the bench. So this is an old brazed carbide parting or grooving tool. There's no carbide on it anymore. I think this is something I raked out of a skip many years ago, and just for the bar stock more than anything, these are normally decent material. So what we're going to do is we're going to cut a section of that off this end, and we're going to mill a slot through the middle of it to take this flat that we've got on here. And if you actually look at the thickness of this, it's pretty much perfect. It's the right thickness, so we can bury that tang all the way through that material. We'll drill and tap one side to put a cap screw in to lock it in place, and then we'll drill and tap in somewhere else in the body to put another cap screw in, or a bit of threaded rod or something that's going to bite against the jaws on the 3-jaw chuck, so that we can use this as a carrier for holding Morse taper sleeves that have got the tang on the back. So not sure how many other times I'm ever going to use that, but once I've made it, I've got it, we'll stick it somewhere, and then if I ever need to put Morse taper stuff up again, I've got a dedicated carrier that will grip on the tang. So we'll crack on with that now, and I'll bring you back when we're making the carrier. Alright then guys, special guest appearance, the new tap follower and the new tap wrench. So I thought I could probably power tap this, but I thought I've made all this gear, so let's give it a try and see whether it does the job or not. I'm liking what I see so far. Well, I'd say that passes the test on both counts. The tap follower and the tap wrench, very nice to use. There we go guys, that's got that done. I'm just going to get the Morse taper sleeve, or the Morse taper arbour. Yeah, that'll do. It's a good enough fit, that. Happy with that. Right then guys, we're set up, so we've got our carrier in position. We've turned a 60-degree cone on a bit of bar stock, so we know that's running true. We've got our revolving centre in at this end. I've got my clock in, so this is the finest resolution, so these are 10th divisions, so between the 0 and the 10 that's a thou, and I'm on centre. So when you clock in tapers like this, your clock has to be bang on centre. If it's not, as you wind down the taper, you're going to get a false reading because the clock's going to be measuring not right on the centre line, if that makes sense. So I know my clock's on centre. I've set my compound slide, so I'll just zoom you in on the clock there. And we'll just wind that out. Best I can measure that, that's 0, 0 each end. There's a bit of fluctuation just in the compound slide when I'm winding it, about half a tenth. So that's as good as we're going to get. And because I'm replicating this taper, because I've blued this and I know it's the right angle, it's dead easy to set this up. I just need to set my compound slide until it's reading 0 as it is there. So we're all set up, ready to go. We'll get a tool it's going to have to be carbide because this is quite hard, and we'll see how this turns. We've not got much to take off it, I don't think, so we'll get a tool set up and we'll give it a whirl. That's horrible material. I don't know what it is, but it just doesn't cut very nicely at all. Anyway, we've cleaned that up as evenly as possible with a bit of emery. So the big question is, does it fit? And the answer is no, because it's now going in too far, and that is a pain. Obviously, because the tape is now smaller diameter, this is travelling in further and it's bottoming out in the bottom of the chuck. So I'll have a little think on what we do there, and I'll bring you back when we've got some kind of an idea. Not the most conventional way to use a lathe, I think you'll probably all agree, but effective. So let's see if that fits now. Right guys, after my rather unconventional way of shortening that taper, which was the easiest way I could think of doing it, and it went okay, we've just blued that up so it now fits lengthwise okay. So we're just going to check the fit and see what sort of taper we've got. So we have got contact all the way down there. It's not the best pattern in the world, but the taper's correct. The surface finish isn't brilliant, and that could be either in the chuck itself or on the mandrel itself or on the arbour itself. Let's just try it again. I mean, it's a good fit. It's grabbing it. It's certainly going to do the job, I think. Yeah, it's possibly slightly big towards the back. So what we'll do is we'll load that back up. Now we're done with the shortening, we'll load that back up in the arbour and we'll just polish this back end slightly, and then I'll bring you back, see if we've got a better fit. Right guys, we just had that back on with the carrier on. We've given it a bit more of a polish, we've re-blued it, and is that focused? I think so. So you can see the pattern I've got there. It's about as fairly uniform as I'm going to get it, I think, with emery cloth and whatnot. So it's contacting all the way down. It's just a little bit lumpy bumpy, but it is a really good fit by feel in the back of there. So what we're going to do is clean all that up now, fit that properly with a persuader, and then we'll see what it looks like. Alright guys, we've cleaned both tapers up in the back of the chuck and on the taper arbour with some methylated spirits, so we know they're clean. So what we're going to do now is fit them together. And fit them together. Yeah, that's not going anywhere. So that's got us out the mire with that. That's mean I've not got to try and send this back. I've not got to order another one and lose my money. So I've now got a keyless chuck for the lathe. So thought that was a little bit different, nothing too flashy and fancy, but I thought it was worth showing a different way of manufacturing a carrier. And I didn't know at the outset of the project, but a different way of machining the end of a Morse taper by sticking a big 20mm solid carbide end mill in the chuck of the lathe. But despite the fact I was a bit apprehensive about doing that, it actually machined okay. And it's worth noting that when I did the machining on that, I actually was using the lock on the tailstock to ensure that it couldn't grab and pull in. So I was winding the tailstock into the end mill against the force of the lock on the tailstock, so it all felt nice and controlled. There was no nasty vibration, so that's all gone well. So I'm pleased with that. We'll pop that in the lathe and we've now got our keyless chuck. I may do some rudimentary checks. I'll do that off camera and you'll see this in use in more of my videos anyway. If you don't see this in use in more of my videos, when I've done some checks on it, you'll know it was absolutely rubbish, and I'll be sending off for another arbour, and we'll be trying again with the right arbour this time. So something a bit different. Hope you enjoyed that. Thank you for watching. Thank you all for subscribing, especially the new subscribers that keep coming along. Much appreciated, and we'll catch you all very soon on another video when we'll be making something else.